In part 1 of my postmortem for my first game on Steam, Broombot Battlegrounds, I discussed the behind-the-scenes journey of how the game got made, and today I'm going to get into the mechanics that I helped implement and how the game itself works. Hello, my name is Nathan, and let's continue talking about
Broombot Battlegrounds.
First up are the primary components of the Broombot itself. The body is simple enough as it's just a cylinder for the collision and another model for whatever custom body was chosen by the player. Yes, this does mean none of the bodies actually give you a competitive advantage, so sorry to dash any hopes there. The same thing can be said about the weapon, except the collision there is a rectangular box instead of a cylinder. These are both pretty straightforward in terms of how they work. The most to talk about here is how the movement works, but I'll get to that in a second. And that's everything important about the Broombot. But like I said, the Broombot is very customizable, as players can select the color, body, and weapon, and nothing else. A fresh copy of the game has a small number of cosmetics to choose from, and as you continue to play, you will unlock more of these items. One of the standouts to me is the color Rust, which progresses from a regular silver color to completely rusted over by the end of a match. It even affects your docking station in Clean of the Hill. The method we use to unlock cosmetics is pretty simple. Each cosmetic type has its own table that lists all of the possible variations. Then we have an integer that keeps track of how many of each cosmetic are currently unlocked, and every time a game is finished, there's a check to see if any of these numbers should be incremented. It rotates which cosmetic type should be unlocked each time. This isn't after every game either, since as you unlock more and more things, you have to play more and more games to unlock these items. The customization menu uses these variables to know which cosmetics to show the players. While the system does work, it's not my favorite bit of code that I wrote, and is one of the things that would definitely be changed if the UE5 overhaul ever happened. I'd probably have a way to mark individual items as locked or unlocked, so that the whole system could be a bit more dynamic. We had gone back and forth on whether we wanted to implement an unlock system based on experience points or completing certain achievements during gameplay, but we decided that the simplest option was the best route given our time frame. One of the ideas was that you could unlock a giant key as a weapon, then colliding that with the chest in the attic level would unlock something else, and so on and so forth. I think that this Easter egg hunt would have been a fun way to collect some of these things, even if it was a hidden feature in addition to the current unlock system. It could provide incentive for players to go around levels they might otherwise not play on to test out theories for a treasure hunt. But again, time and resources will limit creative choices. Okay, there is something else to talk about that I've been avoiding. The eyes. Daniel was the one to write the functionality of these 2D sprites, including when they should react to specific things, but I'm mentioning it now because I found a cool solution to have the eyes work properly on each body. By adding sockets on each of the Broombot body meshes for both eyes, we could find the transform of these sockets in the customization code and use it to know the exact location, rotation, and scale for where they should go. We actually did the same thing at the top of these meshes for placing the weapons on the body. Some body meshes are taller than others, so this ensured that the weapon neither clipped into the body nor was floating above it. Moving on to the movement on the Broombots, there was a small handful of things that we spent a lot of time on to get just right. In order to get the Broombot to move, we went through multiple iterations. The first was simply using the Unreal movement functions, but after realizing that we wanted to have momentum so that they don't start or stop on a dime, we swapped to using the Force. Not that kind. I mean, we would instead add more force to the Broombot while it's moving. However, this ended up causing too many headaches between getting it to behave with other in-game systems and calculating the proper amount to add each frame based on the game's current frame rate. So we brought it back to square one by using the original movement functions, but added enough customization around it to simulate momentum. This actually happened relatively late in development, but it was for the best because it ended up feeling the best overall while controlling the Broombots. Turning the Broombots was much more straightforward because this part didn't need momentum, so the Unreal functions worked perfectly. The only modifications required here were for if the Broombot is in the air to slow the turn speed, or if the Broombot is currently braking to increase the turn speed. I'm proud to claim this last one is my idea to add a bit more combat strategy. Speaking of braking, that's another part that's self-explanatory in that you slow down while holding down the brake button. The ability to dash was one of the primary features that we wanted to have from the very beginning. This one does actually use the Unreal Force mechanics. There are two versions. The first is a quick dash, where you tap the dash button and get propelled forward by a small amount. The other is a charge dash, where you continually increase the dash velocity until you release the button. The size of the arrow that appears indicates how powerful the dash will be. In order to prevent spamming the dash, there's a cooldown for it that changes based on the type of dash just performed. If you quick dash, you get the ability back very quickly, whereas holding the charge dash all the way to the end will take a fair bit longer to recharge. You can tell when you have a dash ready based on whether the indicator is in front of your Broombot. An in-game ring will even appear around you to further indicate that it's ready. The last of the movement controls is a jump, which also uses the Unreal Force mechanics. Fun fact, this wasn't actually planned and was added around 2 months into development as a debug feature. Once we used it for a few rounds, we knew it had to stay. You get a double jump as well that's slightly more powerful than the initial jump. The double jump works on another cooldown system. It's only available for a brief window after the first jump, then it's a small amount of time before another double jump can be performed. Granted, the double jump is given back as soon as the Broombot is properly back on the ground, so the cooldown will only be if you're in the air for an extended period of time or are flipped upside down. Speaking of which, jumping will rotate the Broombot back to be fully upright. The functionality of this is kind of cool since the body collision is instantly fixed, but the animation for the visible mesh gives the illusion that it's taking a bit longer to happen. This quirk is a result of collision issues we found while testing the real version, which would send players flying. In the case that a Broombot is detected upside down for an extended period of time, it enacts the turtle protocol and flips the player upright using the same code. While still on the topic of movement, I want to mention something about dual stick movement. I won't repeat myself because I already talked about dual versus single stick controls earlier, but the original design was dual stick. This is why a lot of the buttons are repeated. For example, the B button is the brake, but the left trigger can be used as well. Similarly, the Y button activates the power-ups, but either of the bumpers also do this. Another way to jump, which I actually use primarily, is by clicking the right stick. We wanted to let players keep their thumbs on the sticks to keep moving, so everything can be activated through the triggers, bumpers, or the sticks themselves. Then for players who are using single stick controls or just prefer the buttons, they have that option as well. We had considered implementing customizable controls beyond choosing single stick or dual stick for these things, but that ended up being out of scope. One of the most important things to get right with this game was the movement, otherwise it doesn't matter how many other cool features we add in. An unfun game is an unfun game. This also includes how the Broombots interact with their environment. The very first time I met with the rest of the team in person at the start of the capstone class, I walked into the room to see that they had already drawn diagrams on the whiteboard for the specific ways they wanted the Broombots to collide with each other. Their first question for me as the new programmer was whether or not these custom collisions would be possible in Unreal, as they had struggled to get these to feel just right in the Unity version. Even though I was still extremely new with Unreal, as I've already said a few times, I knew that there were functions to add forces to objects, so what we eventually ended up doing was creating a framework that would track the states of the Broombots and apply the proper forces when specific collisions were triggered. To list off a few of these custom collisions, the basic body-to-body collision is meant to feel like bumper cars. Hitting your weapon against an opponent's body propels the other Broombot much further. Striking the side of your opponent's weapon will stun them and spin them around so that their balloon is exposed, and hitting weapons together head-on,
applied directly to the forehead,
will result in both players being stunned and sent backwards. There are also custom environment collisions, such as bumping into a wall will push and turn you away from it to avoid getting stuck, and driving headfirst into a wall with your weapon will cause the same reaction as the head-on collision with another player's weapon. Speaking of interacting with other players, let's talk about the combat mechanics. Now obviously, a lot of this was just covered while discussing the movement and collision systems, but players still needed a way to destroy each other. This is where the balloon comes in. Whenever a player's balloon gets hit by another player's weapon or a hazard, that player's Broombot explodes and any necessary points are awarded to the other player. And that's all there is to say about the balloon. No, I've been avoiding it, but it's time to talk about the one thing that was the bane of my existence for most of the development of this game, the balloon physics. Without a doubt, this one seemingly simple mechanic caused so many headaches for me that I questioned whether I wanted to continue working with the project many times. The It movies wish they could give me this much balloon-related trauma. I was even considering lobbying to remove the balloon altogether at a few points. Of course I couldn't do that because it's such a central feature to the idea, going back to the Rooster Teeth video that inspired Broombot in the first place. I probably spent more time on this little submenu than I did any other single thing in this entire project. It started out fine enough, with Carter just adding another mesh component to the Broombot, attaching it to the body with a physics constraint, and letting the balloon just ragdoll around, right? Wrong. Immediately we realized that the balloons would very easily get stuck in walls or under floors that were too thin. This part wasn't too much of an issue after some tweaking, even though it wasn't still totally fixed, but little did we know that that was just the tip of the iceberg. Remember when I said that the jumping mechanic wasn't initially intended as a feature? Well, the addition of it showcased another flaw with the balloon, which is that it had the ability to move the Broombot that it's attached to. Now you might be asking, how is this a problem? It was a huge problem actually, because every time you jumped, the balloon would knock you off course and cause you to start flipping upside down. Additionally, if the balloon got even a little stuck on something, you were completely unable to move. We wanted the balloon to feel weightless and out of the way, you know, like a balloon? But instead, it had started to feel like a ball and chain. Not only that, but you could actually land on your own balloon, causing a vicious cycle of not being on the ground properly due to the balloon, jumping in an attempt to fix it, and then landing on the balloon all over again. Adding some constraints to how far the balloon could swing helped with the jumping part, but it still remained an issue if the angle you landed on wasn't just right. Not to mention the fact that constraining how far the balloon could twist to move away from things behind you made it incredibly easy to have your balloon detach and fly out of the map, killing you instantly due to the save zone if you had the audacity to back into a corner. This was actually the version of the physics that was used in our first DePaul showcase, and yes, it adds a bit more chaos, but it's still frustrating nonetheless. There is a setting to make the balloon unable to collide with the body, of course hidden in another stupid checkbox, but that created a whole new issue with the balloon being able to phase through the body whenever it wants. Again, constraints help to simulate the balloon hitting off of the body, so now if you landed on the balloon, it would just move over. It was then able to get stuck in walls or under the floor pretty easily again, so finally we added a point to the end of the balloon, and if it did not have direct line of sight to the body, the position of the balloon would reset. Naturally, this came with its own set of headaches, such as needing to have invisible objects with their own collision type that don't count as breaking the line of sight, since they would force the balloon to stay perpetually in the reset position. Another issue was that if you stayed on the edge of a cliff with the balloon hanging over at just the right angle, the balloon would seem to bounce up and down. Fun fact, this is still in the game, as this was the final version that we settled on before I nearly killed. Another problem we kept encountering centered around collision with loose objects in the levels. Part of the custom movement system accounts for running into movable objects, such as blocks, by slowing the player down a bit. This ensures that things feel like they have real weight. However, this only happens when it's the body or weapon colliding with the object while moving. The balloon has its own collision requirements, meaning that it wasn't that hard to reverse into a set of objects and go full speed. This is due to the fact that it was placed between the Broombot and whatever was behind it. While we did get this part mostly fixed, there was another problem, this time with turning. You see, the turn speed is adjusted when it senses that your weapon is turning into an object, so all good there, but the balloon is off doing its own thing because we are now at the stage of having the balloon being completely subservient to the movement of the body. This means that turning your Broombot into an object essentially gives you super strength. We tried to fix this, but there was only so much we could do at that point. All of this might not seem like that big of a deal when it's summarized for a video like this, but you have to remember that this process was spread out over several months with a lot of trial and error before arriving at the next solution, while also trying to work on everything else in the game at the same time, as well as completing work for other classes, and you can start to see with my frustration with needing to return to this stupid balloon so many times when I kept thinking that I was already done with it. Moving on. In terms of what you can do in the game, there are a handful of game modes available. Earlier I briefly touched on the need to refactor the game modes, and I want to add on a little bit to that here. Like I said, the core mechanics of player destruction, respawning, and timers were all able to be put into a master game mode class. From there, the individual game modes would function like a state machine to decide things like when to use the timer, whether Broombots can respawn, when players should earn points, and even more mode-specific features such as behaviors for Dust or the Oddbot Crown. Creating this framework cleaned up a lot of redundant code and made it way easier to create new game modes, since most of the work was already done and only required the implementation of new features. Getting into the actual game modes, first off are the two focused purely on combat. In timed battle, you get a set amount of time to battle your opponents, getting a point every time you destroy another Broombot. Whoever has the most kills by the end wins. Last spot standing is instead round-based. What this means is that there is no respawning, and whichever player is the last one remaining at the end of a round gets a point. After that, everyone respawns, and this continues until someone has reached a set number of points. This game mode actually has the option of staying on the same map, or moving to a new one after each round, either randomly or in order. We had also considered adding a stock battle game mode, but it seemed a little redundant since we already had two game modes dedicated purely to combat. The Clean of the Hill game mode was one of the core features the original team wanted to implement. In this mode, the focus is shifted to collecting dust and other small objects throughout the map. The dust is stored in your balloon, which grows as you collect more. This doesn't count as earning points, however, since to do that, you need to return to the docking station that you spawned in to deposit your dust. You'll want to do this quickly, because if you are destroyed, your dust is scattered, allowing your opponents to pick it up. The more dust you collect, the larger your balloon grows, literally making you a bigger target. Once the timer runs out, the player that deposited the most dust wins. Daniel was the one that took the lead on handling the dust and its behaviors, including being picked up, appearing after a Broombot is destroyed, when and where to respawn after being deposited, and making an object pool for the individual objects. I came in a bit later on this to help with optimization by transferring the dust objects to lighter C++ classes that are more manageable and efficient. There were a lot more revisions to the dust that would take too long to get into here, but I will note that we had originally considered using 3D models for the dust particles before the current 2D sprites. Oddbot is the odd one out here because it was added much later, even after the game was initially released. In this mode, a crown is spawned on the map that bounces around. When a player obtains the crown, they will earn a point for each second that they are holding on to it. While holding on to the crown, there are two possibilities. The first is that another player destroys them and the chase for the crown is back on. The other is that they hit the score to win and the game ends, making them the king of the hill. Wait a minute. Before the game properly begins, there's an optional warm-up round to let new players figure out the controls. Once everyone is warm enough, they can ready up and the actual game will start. On this topic, there was this one group playing Broombot at PAX that started on the warm-up round. One player that didn't know the other three had hit the ready up button, despite the other players mentioning it multiple times. After about 10 minutes of this, he puts down the controller and walks away. I'm pretty sure someone else picked it up so that the others could see the real game though. This is what prompted the addition of the text at the top of the screen that slowly grows more and more passive-aggressive with its instructions. Lastly, if there are any ties at the end of a game, the tied players enter a sudden death mode for the final point. Now you might have realized that some game modes are better suited to specific level sizes. For example, the two battle modes would be somewhat boring if players took forever to find each other, so the available levels to choose from are more small and medium-sized. On the other end, Clean of the Hill and Oddbot both require much larger maps. In Clean of the Hill, there needs to be enough room to let the dust spawn for players to actually go around searching for it. Oddbot requires the space to allow a more active chase of the crown, as well as letting the player who has the crown properly run away from everyone else. Speaking of levels, I didn't really work on most of the levels, but I wanted to briefly mention them. While pretty much everyone contributed in some amount to the design of various levels, Carter was the one that built basically all of them. One of these is the test level that we used for working on most of the movement and combat mechanics, which is actually still available to play on in the official release, if you know the secret. The main focus was to keep the Broombots in a house, so a lot of the level themes are based on various rooms, such as a kitchen, a basement, a bathroom, an attic, a dining room, a children's playpen, and a home gym. The classroom level isn't in a house, but it's still somewhere a cleaning robot would make sense to be at. The idea stretched even further with the additions of a backyard and a frozen over pool, places that, while yes, are connected to a house aren't typical locations for a cleaning robot to be. Finally, there are the levels where we abandon the home concept altogether in favor of putting the Broombots in cool locations, such as a factory, a classic diner, an aquarium, and a construction site. The construction site was actually based on another concept we were working on early in development, which was called High Ground. The 2 levels from post-release updates continued this trend by being set in a boiler room and a sewer. With this level variety and the questionably changing scales of the Broombots, on top of the game concept in general, I think it's clear that realism was never a main focus for us. Each level has its own set of unique features and hazards, with some of my favorites being the knife that chases you if you try entering the kitchen in the diner, the glass in the aquarium breaking and flooding the bottom floor if you run into it, the collapsing trapdoor and electrified water in attic, the putty potty in the bathroom, the ice in the frozen pool combined with the inflatable flamingo that flings you around, the conveyor belts in Box Factory, the wrecking ball in Hard Hat Zone, the stovetops in Island, and the working game of pool in the basement that will actually give you a power-up balloon if you complete it. I do have to give special shoutouts to the 2 best ones in the game. The first is that if you try to escape the garden by hopping over the fence, you very quickly get run over in the street. Side note about this one that's a bit hard to get a clip of, but the car will actually veer into the sidewalk to ensure it hits you after it's triggered. This can lead to even more hijinks if you teleport across the map quickly enough. The second one is the fact that you can trigger an entire meltdown process in the boiler room by hitting the valves around the map and then sacrificing a Broombot to the furnace. This is a great showcase of some of the other side quest type features we wanted to add in that I touched on earlier. While I was primarily working on other parts of the game, I did have my hand in some of the maps. This mostly includes small touch-ups as I was working with the lighting or implementing one of the many frameworks. However, there were some noticeable features that I added. Some were smaller details, like adding more color to Hard Hat Zone or adding the backsplash to Island. Others were more about Easter eggs, like causing the music to skip when you run into the jukebox and diner. I was also the one that created the sudden death map, since I needed a placeholder while creating the game mode. This level is a prime example of my design philosophy of, you know what would be absolutely hilarious? With its simple shrinking platform, spikes in the ground, and lake of lava. The music was also supposed to be much more over the top than what it currently is, but I'll circle back to that when I talk about the music. It's also a good example of what we were and weren't able to finish, because aside from the music, I wanted there to be more detail to the platform. I mean, the current version is actually still using the placeholder texture that's literally the same one I made for the planet in Solar Shield. Another addition I wanted to make was maybe even a cage or a crowd. Some of this would be reused in a different unfinished level, but again, more on that later. The only thing we had time to modify was swapping the knives on the ground with buzzsaws. The level I spent the most time working on by far was the sewer. Daniel originally created the layout as a testing ground for other features, but we all liked it so much that we wanted to turn it into a proper map. I forget how I ended up being the one to take point on it, but it was a fun change of pace. Without changing the layout too much, I added most of the details in the textures, set the water to intermittently rise and fall with alarms going off, made the water glow as the toxic barrels were pushed in, and added some ambiance with trash floating down the river and mice running between the holes in the walls. After I needed to shift focus away from the sewer, Carter and Daniel took over to make some adjustments and add the tentacle that pulls you into the river if you cross it. In order to actually see what was going on in the game, we needed to have cameras that would track the players. The relatively smaller levels used by the combat game modes were designed to only require a single camera that would adjust itself to keep all the players in frame. Daniel took the lead on this camera, but we soon found out that it would be a bit more involved. We wanted the game to be viewed from an isometric view, so naturally we used an orthographic camera. As a brief summary for those who don't know, the 2 primary ways to view something in a game are called perspective and orthographic projection. The 2 types project a view from the in-game world to the screen differently. Perspective is how we see the world, where things that are closer appear larger than things that are further away. Orthographic, on the other hand, shows everything as if they were all equidistant from the camera. This can be useful for creating isometric views that are commonly used in a lot of games. However, there is a quirk to using orthographic cameras, especially in Unreal Engine, which is that you no longer see the dynamic shadows on movable objects in the game. Our way around this was to swap back to a perspective camera. You see, if you move the camera really far away from what you're looking at, but then zoom it back in, it creates the illusion of being an orthographic camera while still drawing the dynamic shadows. There was a lot of fidgeting around to keep the mostly orthographic view, since the dynamic shadows would disappear again if the camera got too far away, but then would shift back to a perspective view if the compensation brings the camera too close. This resulted in a sort of hybrid view, where everything still appears isometric, but you can tell that it's not exact by how the perspective shifts a bit when moving around larger objects. I actually prefer this look, since it adds a very nice sense of depth to the world. The math to juggle the moving players while maintaining the isometricness was further complicated by the adjustments for the shape of the screen. My main monitor from my PC is an ultra-wide, so I noticed that the view was noticeably different when I had it in a standard 16:9 window versus in full screen. This prompted us to account for any non-standard screen size by calculating the ratio of the current game's window's width and height, then using that to adjust the camera location. Not only did we need to modify the camera, but this also got us to fix up the outside of the levels. Prior to this, a lot of the larger levels would seem to trail off outside of what is normally viewable, kind of like on a television set. Now, all of these levels have their edges cleaned up. It wasn't much of an issue for the smaller levels or ones that are in rooms, since those had clear box-like cutoffs, taking inspiration from other games like Captain Toad. Speaking of the larger levels, the game modes that use them require individual cameras for each player in a split-screen view. Creating the cameras was easy since it was essentially just the other camera we had already made, but instead only following one player. However, this is where I need to rant again for a moment. When creating a multiplayer game that requires split screen, what is the best way, or even just the way that makes the most sense, to go about doing this? No, genuinely, you watching this right now, how would you think adding multiple camera views to the screen should work? Actually pause the video right now and think about it. Maybe even write it down in a comment. I'll give you a second. Are you good? Okay. The way that this should work is that you first put however many cameras in the level that you need. Then you take whatever each camera is seeing and you give it a spot on the screen to show its contents. Very straightforward and easy, right? Apparently not, because Unreal had to come out here and make my life specifically ultra difficult. Working with this was just as bad, if not even worse, than the balloon physics! The way Unreal does it is that the number of screens is tied to the number of controller objects. So, if you have 2 controllers, you get 2 screens, and the same for 3 or 4 controllers. Then each controller has a unique player ID that is created when it's plugged in, starting from 0 and going up. While this is extremely limiting, this alone is not the biggest issue. The biggest issue is getting this to work with our game specifically. You see, we needed to account for controllers being connected but not in use, like if someone wants to sit out around. This means that in the customization screen, any controller can join the game and be player 1, 2, 3, or 4. However, if the controllers are out of order, suddenly we need to track the controller ID of each player. And no, you cannot just reassign the ID of a given controller. Attempting to do so will just swap who is controlling what. Now, everything dealing with player IDs and their cameras in-game requires constant back and forth between the player ID and the controller ID, and it's not always clear which one a given function is asking for. This is a huge issue when creating a pawn and attaching a camera to it for proper display. The need to account for this constant shuffling between the 2 ID types and balancing the pawn with the cameras required so much more work than what it should have been if Unreal had a normal camera system. On top of this, remember how I said that the number of camera views was tied to the number of controller objects? Well, you need to delete any unused controllers before the game starts, or else you have an additional split view. But this requires even more shuffling, since if there are any controller IDs higher than the one being deleted, all of the other in-use IDs need to be shifted down by 1 to make sure that they're controlling the proper player. There are a lot more migraine-inducing details that I'm leaving out, but someone please tell me how this is supposed to make sense. Like, I understand that local split screen is not nearly as big of a thing as it used to be, but I'm just absolutely baffled by some of the design choices made in this engine. Honestly, I've given a lot of thought to how I would go about working on this game differently if I were to start over, and I would strongly consider moving to Godot just for the better camera viewport. And yes, I am aware of the ability to cast the camera view to a texture in the UI, which works exactly how I've been saying the camera system should work, but that causes the FPS to tank when you remember that this game requires up to 4 of them. Like, my PC goes from an average of 120 FPS on the test level to less than 15 FPS with the UI workaround. On the topic of hazards to my health, let's move on to the in-game hazards. There are the obvious ones, like various pointy objects, fire, electricity, slipping in the water and on the ice, slowing down on carpets, and various things bouncing the Broombots around. There are 2 more that are a bit less apparent, both with self-explanatory names. The kill boxes, plural because there are a few variations, kill the player if they run into them. The other non-standard types include triggering deaths by fire, water, and electricity, which is how some of these other things kill you. There were times in testing when players could fling themselves well outside of the map, as well as some pits where you could dodge the kill boxes when falling into them. To counteract this, each level is encapsulated by a safe area that blows you up if you try to leave it. This way we have a catch-all for any missed edge cases.
Broombot Battlegrounds.